This is a heavy barreled Remington 700 in 308 in an Accuracy International AICS folding chassis system. That's quite common for UK civilian shooters, but this rifle belongs to one of the UK Police Force's rifle teams. And usually in military and police circles, most customers use their rifles until they're worn out and then they destroy them and buy a new weapon system. And as the UK Warranty Centre and Remington Defence's distributor in the UK to police and military, we get the opportunity to educate police and military end users that the only thing on the rifle that wears is the barrel. So this rifle has come to the end of its working life barrel-wise, and unlike most teams that would just get rid of or destroy the rifle, we're going to rebarrel it for them and bring it back to as new or slightly better than new condition by fitting a select match stainless steel barrel to the same 22-inch length, although we're going to change the twist rate. This rifle right now is a 1 in 12 standard factory twist. We're going to go up to a 1 in 10 twist so that they can shoot heavier intermediate barrier rounds. But we're going to fit it to the same 22-inch length. We're going to refit the customer's SL5 moderator, but we will Cerakote that black. We're going to Marine Tex bed the gun onto the chassis, and we're going to fit a replacement trigger unit. We've shot this rifle, and because it's at the end of its barrel life, it's shooting just over an inch, which is perfectly acceptable for a hunting rifle and is perfectly acceptable for a target rifle, probably out to 600 if you're just shooting recreationally. But where police snipers or police rifle officers have no margin for error, this rifle will have to shoot very, very well for it to be deployed. So we're going to rebuild the rifle in a slightly higher standard than they're used to, but is more akin to what a civilian marksman would be used to. And here you can see the same rifle stripped down to its component parts. We're not going to be blueprinting this action because that's not what the customer requested, but we are going to clean up the threads in the action prior to fitting a new barrel so that we get a very good fit between the barrel and the action. We're also going to fit a tactical bolt handle to make ease of bolt lift after firing, and we're going to refit the customer's Assay Ultra S5 moderator. So we're going to match the 3/4 by 28 thread on the end of the 22-inch barrel on the new barrel. As most of you will have already seen all of the steps necessary to rebarrel a rifle, I'm not going to bore you with the whole process, but I will take you through the steps. So here the barrel is set up in the chuck and is dialed into the bore, and the other end of the barrel is dialed up in a spider. So we've got 0 run out on the bore, and then we've turned the profile ready to accept the thread, and you can see there is an unthreaded shoulder here which is left on there for the recoil lug to sit on, and then the threaded shoulder is turned up with a thread relief in front of the recoil lug ready to match the action. So we'll cut the thread next. The thread in the action of a Remington 700 is 1 1/16 inch, 16 TPI or 16 threads per inch. So to set the lathe up to cut a 16 TPI thread, we set the gearbox in accordance with the chart here. 16 TPI is Charlie 1 Sierra Yankee. So we set the gearbox to Charlie 1 Sierra Yankee, and we need a 16 TPI insert in the end of the tool holder. So in the end of the tool holder here, there's a removable insert that cuts a 16 TPI thread profile, a fully formed insert. And I've set the machine up to make the first pass, so that's only 10/1000ths of an inch deep, and the first pass will go through the part, across the part, and then the tool will stop in the thread relief, and it does that every time with every sequential pass at 10th thou per cut until the thread is formed. There it goes now. And stops automatically in the thread relief. I can then bring the tool out, come back to the starting position. Go into 20 thou. And with each pass, it stops in the thread relief. And that's how you form the thread. That's the thread cut, just a little under 8 passes at 10 thou per pass to get to thread depth. And now we'll offer up the recoil lug and the action. Because it's a freshly cut thread and it's a good fit in the action, we don't want to gall that thread, so we'll just put a little loop on there. And you want a good fit for the thread, but you don't want the thread too tight that it galls in the action or binds in the action. And you want the recoil lug pinching up without any movement whatsoever. Doesn't matter about the orientation of the recoil lug at the moment, because we'll sort all that up when we screw it back together again. But yeah, there you go, action threaded. The next job is to cut the counter bore for the bolt head on the Remington to sit into. And this is the counter bore tool. We fitted the pilot that we used to dial the barrel up on the range rod. We fitted that to the counterbore tool. The counterbore tool is ground to the correct outside diameter, or 705 thou, to cut the recess for the Remington bolt head. So we'll go ahead and start cutting the counterbore. That's the counterbore cut to dimension, and what I've also done is I've broken this corner here, which is what forms the feed ramp on the barrel of a Remington 700. But also I do that before I start the chambering process, so that I haven't got the reamer going in and out near a razor sharp edge that I've just machined. Having broken that corner and formed the feed ramp just makes it safer when I'm performing the chambering process. Okay, I'm going to chamber the barrel now, and I'm not going to bore you with the whole process. I'll just talk you through some of the technicalities. We've now put the same pilot that we used onto the chamber reamer, and we use two reamers. We use an undersized or rougher reamer to cut the majority of the material out, and then we go to a full CIP finishing reamer. And the reason we do that is to save our tool wear. So the roughing reamer will remove most of the material, and we'll go to within 200 thou of correct dimensions. And then we'll change to the finishing reamer to make the finishing passes, and then we can polish the chamber and get a very, very good chamber without ruining our finishing reamer. and we'll go through 3 or 4 roughing reamers for every finishing reamer that we use. With the chamber now cut and the action screwed on, all we've got to do now is check the headspace dimension with the go and the no-go gauge. And so these are ground to dimension. Fit the go gauge in, and the bolt obviously must close on the go gauge and must not close on the no-go gauge. So now we're at dimension. We can now go ahead, polish the chamber, make sure the dimensions are still correct, and then we can turn our attention to the other end of the barrel. And the last job on this barrel, once we turned it round and got the muzzle end in the lathe, is we've turned down the 3/4 by 28 thread to accommodate the police force's suppressor, and we've cut a 2-part muzzle crown. So the first part, the initial reset, is at 158 degrees. That recesses the crown to protect the crown from physical damage. And then there's an inner crown cut at 60 degrees, and that's the true crown. And we tend to cut that last crown by hand. So we rotate the chuck by hand, and we can feel the cutter cutting into the material, and you can tell the point when you've got through the lands and into the grooves. And then once you've cut both lands and grooves, then you can finish. So we'll take that out of the lathe and look at the components. For those of you who haven't seen how we put a tactical bolt handle onto a Remington 700 type bolt, this is a standard Remington 700 type bolt, and the angle between the axis of the bolt handle and the axis of the bolt body is approximately 110 degrees. And we've tried making them on the mill, and we've tried several of the commercial fixtures to hold the bolt. In the end, we made this fixture ourselves to hold the bolt at exactly 110 degrees so that we can turn the bolt handle down from its original knob shape to a cylinder. We turn it down to an 8mm cylinder. We thread that cylinder, and then we can screw a tactical bolt handle on, which also, it gives you slightly longer bolt handle, which gives you more leverage on primary extraction, but also it gives you a bigger bite to get hold of the bolt. It gives you more leverage, more purchase when you're opening the bolt from the fired position. And here you can see the bolt handle fitted, and you can see that over a conventional Remington 700 bolt, it offers additional length and additional purchase for opening the bolt. So here you can see the finished components, the customer's old barrel at the back, the action rebarrel in 308 in the middle with the customer's S5 fitted to the muzzle again, and the customer's bolt with the tactical bolt handle fitted. So obviously we'll have to put a trigger back onto that rifle, and we'll have to put the firing pin mech back in. But that's how it goes to proof, as a barreled action with a bolt. Next we're going to bed that barreled action into the customer's stock prior to the metalwork going off to proof. This is the chassis system that's underneath the stock panels on an Accuracy International AICS chassis system for a Remington 700. And at the customer's request and at our suggestion, we're going to synthetically bed the gun down to the chassis. And a lot of people believe that there isn't any benefit in Marine Tech's bedding a rifle down onto the chassis system. And we would suggest, if you don't believe there's a benefit, then shoot your rifle before it's bedded, bed the rifle, and then shoot it again. Because we've never seen a rifle shoot worse, and we routinely see rifles shoot considerably better when they're synthetically bedded onto most of the chassis systems. But on this chassis system, it's only necessary to bed around the front and the rear action screw area, and specifically the recoil lug pocket here and the bed in the chassis system behind the recoil lug and on what's called the tang area at the back. And this is the most important area here around the recoil lug pocket, and that prevents the rifle from moving within the stock backwards at all during recoil. Around the tang area, it stops the gun from being pulled down or torquing the action when you do up the action screws. Once you've bedded this area, it's vital to bed this area so that you don't get any flex in the action when you do up both action screws. We've already sprayed, we've degreased the whole of the barrel action, and we've roughened the surface or broken the anodize on the surface of the chassis system, and then we've thoroughly degreased everything with blast degreaser, and then we've put a silicon release agent. We use this aerosol material you can see here. We've put a silicon release agent onto the barrel and action, and we've put wax onto the action screws so that when we do the screws up within the action, we don't glue the gun into the stock. And the bedding material we use is grey Marine Tex. It's pretty much the industry standard for bedding synthetic stocks and for chassis. And it's the material I was taught to use when I learnt how to bed rifles at Macmillan Fiberglass Stocks. And the easiest way to apply it's an epoxy material that you mix with a catalyst, and then you apply to the rifle stock, and then you apply the rifle down and do your screws up. But the easiest way to put the material in place is to pack the material into a syringe. And this is a little trick that I was taught by Darryl Holland of Powers in Oregon when I was learning with him. And it's very easy to apply the bedding material exactly where you want it to go. And since I was taught this little trick, I've shown this trick to the Remington Custom Shop, to gunsmiths across France and Germany, and as far as Australia and New Zealand, I've shown people how to do this. And it's a very, very cool trick. I'll show you why. I need to put bedding material into the recoil lug pocket and into these two areas, but I don't want it spilling out all over the place. With a syringe, you can apply the bedding material in an even thickness over the whole area without getting great big voids in the bedding, which means you don't get air bubbles. And when you squeeze the rifle down into the stock, you don't want air bubbles in your bedding. Using a syringe to apply your bedding compound, it means that you can get a very uniform coating onto the areas where you want the bedding material to go. Like I say, I want to get some into the recoil lug pocket. And onto the tang area. And then to make sure I get a good uniform coat, I'll put a small bead at the back of the recoil lug here to make sure I get a good edge on my bedding. And then with the action placed onto the chassis and the screws done up, you can see the bedding material oozes out around the action, and it's a simple matter of simple Q-tips and methylated spirits. And you soak the Q-tip in methylated spirits, and you can wipe all of the additional oozed out bedding material. And clean the rifle up. And the amount of time that you spend cleaning up now while the bedding material is not set will save you a considerable amount of time at the end of the project when you're trying to machine out bedding material which isn't where you want it to be. So the amount of time you spend now tidying up the chassis is time well spent, I assure you. It's a lot easier to clean it up now than it is trying to bugger about after it with a vertical mill after it's set up. When it sets up with about the same tensile strength as aluminium, and consequently you won't be scraping it off with your thumbnail. And at the back here you can see I've already started to take the material off around the tang. And while it's uncured like this, the bedding material, the marine text, is relatively easy to clean up. And you leave that to set up overnight. We tend to leave it for at least 24 hours. Let the material cure properly, and then we'll show you how we get the rifle out of its chassis or out of its stock, and how you tidy up afterwards. One last thing, when you leave this rifle to cure, do not leave it on a rifle vise with the barrel action bearing down on the stock. That will make the bedding thinner at the front than it will at the back. You should always hang the rifle from the barrel. And here you can see this is a rack that we've constructed specifically for the purpose of leaving rifles to cure while they're being bedded. That the whole of the weight of the rifle is being supported by the barrel, and the stock is hanging off the bottom of the action. That makes sure that as your bedding is set up, it's completely uniform over its entire length. And that tiny little difference is the difference between an excellent bedding job and an average bedding job. I did promise to explain, when we've popped the rifle out of this chassis, how we get the two apart, and show you the tricks of the trade, if you like. Unfortunately, when I went to take this one out of its stock, it literally fell out. So I couldn't show you very much. So we've got another rifle that's bedded here that we'll show you the trick with. The problem is, after you've bedded the rifle, you can't rock the rifle, the barrel action, out of the stock to get the two parts apart, because you'll damage the bedding in the recoil lug pocket area. You need the barrel action to come straight vertically out of the stock, preferably in one go, without any rocking action. And somebody else taught me this trick, and it's very, very simple. You have a plastic bin we've got an apron hanging over there. You undo the stock bolts, and then you hold the barrel action by the barrel, and then you strike the action on the front receiver ring with a rubber mallet, and the shockwave goes through and pops the rifle stock off the barreled action without damaging the recoil lug pocket at all. And it's as simple as this. The barreled action comes off the stock, it comes off perpendicular, so it comes straight off, and there's no damage in the recoil lug pocket area whatsoever. Easy, simple trick. And here is the police sniper rifle finished. As we said at the start, the only thing that wears on the rifle is the barrel, and rather than change their fleet of sniper rifles, we've just MLI'd or midlife improved their existing rifles. So here you can see the old barrel in the foreground, and on this rifle we've changed the barrel out for a proof research stainless steel barrel. We put a tactical bolt handle on the rifle, changed the trigger out to a Trigger Tech trigger. We marine text bedded the whole rifle back into the Accuracy International chassis, and then we cerakoted the barrel action and the customer's Ace Ultra moderator on the front end. So prior to us doing this, to change out their rifles would have cost the authority about £3,000 per rifle. Doing this has cost them less than £1,500 per rifle. And prior to us doing the work with the old barrel on the rifle, shot over an inch, and with their operational ammunition, the rifle now shoots under half an inch, or .493, which is the target, which is with the rifle, and with Lapua match ammunition, the rifle shoots .335. So not only are they getting very, very accurate rifles back, but they're getting incredibly good value for money. And the proof is in the pudding, obviously. Thank you.